All right, why don't we go ahead and get started? Good morning, good afternoon, good evening, everyone, depending on where you are joining us from. And thank you for taking the time out of your day to join us. I'm Caitlin Barnard. I am one of the members of our developer marketing team here at Kong, and I would like to welcome you all to Tech Talks by Kong. So Tech Talks is a webinar series dedicated to our developer audience. We feature open source products and topics relevant to you with more extended live demos. So at the end of the presentation today, we will open it up for Q&A and discussion. So please feel free to use the chat function throughout. But if you have any questions today for Charlie, please make sure to enter those in the Q&A at the bottom of your screen. So that'll help us keep track of them and make sure we get to all of your questions at the end. This is being recorded, so you will receive a copy of the recording and slides via email within 24 hours. So I would like to welcome our speaker today, Charlie Moltaire, who is our engineering manager of our mesh team here at Kong. So Charlie today is going to be talking about the magic of service mesh and everything that your sidecar does for you. So with that, Charlie, I will hand it over to you to get started.
Hi, everyone. Thanks, Caitlin. Thanks, everyone, for joining. So as said, I'm going to talk about the magic of service mesh. So why am I giving this talk? A lot of things have been said around sidecars recently. And so I was looking for good content for people to try to get a better understanding of what sidecars actually do. And I couldn't really find anything for that. So I've decided to try to get a stab at it and maybe bring something, some knowledge that is useful to everyone. There's 3 different levels at which you can take this talk. Either you're completely new to service mesh, or you might not even be interested in using a service mesh. In that case, it's just pure engineering culture. Just learn how it works. It's an interesting pattern. Maybe it's reusable somewhere else, whatever. The second level is you're already a user of service mesh, or you're starting your service mesh journey. This will teach you a little bit about the internals, and it's always good to understand a little bit about how the tech you're using actually works underneath. And then finally, if you're already a user of Kuma or Kong Mesh, this will teach you a little bit how to troubleshoot and leverage some of the internal tools that we provide to help users in their journey. So a service mesh architecture, if you take Kuma or Kong Mesh, is all that. It's multi-zone, there can be external services, there's a bunch of CPs, etc., etc. That's a lot of information. So for this talk, we'll go to the smallest possible deployment, which is a control plane and a bunch of services. These services in Kubernetes, they're pods. So you have multiple instances of a service. They all connect to the control plane. And then each of these services have a sidecar next to it. In the case of Kubernetes, you get a pod and you get 2 containers in that pod. One is the sidecar and the other one is your actual app. The services are going to talk to one another through these sidecars. The entire traffic from the service is redirected through the sidecars. The most common ways to do that is by leveraging IP tables, but there's different possible ways to do that. So why a sidecar? A sidecar is a very simple security model. It's very similar to what you do with Kubernetes, which is the pod isolation. It's imperfect, but if you've decided to go with Kubernetes, that's probably a trade-off you've already considered and evaluated. Similarly, containers did a lot of work to achieve multi-tenancy. Multi-tenancy is one of the hardest problems in computer science, and containers through C groups have actually done CPU and memory isolation in a pretty okay way. It has also great failure isolation, as in it's already what you've considered. When your sidecar crashes, your pod loses connectivity. It's very similar to your pod actually crashing. So it's probably something you've looked into and you're already trying, even without a service mesh. So adding a service mesh doesn't introduce another layer of complexity, another layer of failure cases that you need to consider. In a similar manner, your sidecar is going to scale exactly like your app does. So if you need more capacity, you'll increase the number of pods you have. This is different that if you have a proxy that is external to your pod, in which case you have 2 dimensions. And these things don't add up. They actually multiply together in complexity. So when you need to scale up things, do you need to add more proxies? Do you need to add more pods? Do you need to add both? This is a lot harder to figure out, to reflect about than when you have a one-to-one mapping, like with the sidecar pod, with the sidecar per instance case. And then finally, upgrading your sidecar is exactly like upgrading your app. You just restart it. It's pretty fundamental in the construction of things like Kubernetes that a pod is ephemeral. You just recreate it when you do. If you cannot restart your application, the problem is not with the service mesh. The problem is with your application. You should work very hard in being able to restart your application fairly often. So with the sidecar, it's only becoming a forcing factor of you being able to restart your apps quite easily and quite frequently. These arguments have been talked more at length in this article by William Morgan, and that I invite you to check out. So what do control plane and sidecars do together? When your sidecar actually starts, it will connect to the control plane. It will send to this control plane a token and some metadata about the actual instance running. The token, in the case of Kubernetes, happens to be the service account. The control plane will verify this token and generate the sidecar configuration that matches the state of the mesh. So what is the state of the mesh? The state of the mesh is the different policies that apply to your to your instance. What we call policies are different configurations that you can set in your mesh. So things like retries, timeouts, but also security configurations like your certificates and things like that. But it's also all the different instances of other services that your sidecar are going to talk about. We'll go more at length in there, but your sidecar will enable you to specify your load balancing strategies and stuff like that. So once it has computed all this configuration, it will send it down to the sidecar. The sidecar will transparently reload this configuration to be able to be up to date to receive and send traffic as it needs. It's very important to understand here that it's transparently reloaded. And that means you don't need to restart your sidecar. You don't really need to do anything on your application stack. This is quite useful. For example, in the middle of an outage, when actually, for example, reducing the size of a connection pool to free up some capacity or returning more proactively errors would actually get you out of an outage. If you're using a library in your application, this might be something you can do. You can set the size of your configuration of your connection pool. However, this is not something you're going to be able to transparently set and reload without changing your app. This can make a big difference when you're trying to save yourself in an outage, trying to get back to a normal state so that you can get back in proper order. You probably don't want to restart everything when things are burning. So whenever the state of the mesh is going to change again, the control plane will regenerate this configuration and push it again to the sidecar. This is done in the loop, and you don't really have to do anything on your side. This is all dealt by the service mesh. So now we'll do a little segue where I need to introduce a little tool for the rest of this talk where we'll walk through a set of examples. So Envoy has a pretty complete admin API It's so complete that you can do things like shutting down your sidecar through that. Obviously, we don't want to expose that anywhere too widely. So we provide a way through the control plane to actually access this API. To access this API from either RCLI or the GUI. From there, you can access 4 different types of inspect APIs. The policy API that lists all the policies that apply to your data plane. The config dump API that gives you the full Envoy config dump. This is very verbose and very complete, but sometimes it's the best way to actually figure out deep and complicated issues. The stats API, which is very similar to what you'd get in Prometheus, but this is live, and sometimes it's just easier to connect to the sidecar and just get the latest and up-to-date information that way. And then finally, the clusters API. A cluster in Envoy is similar to a service in Kubernetes. So behind a cluster in Envoy, there's a set of endpoints. And so with this API, you can get very in-depth statistics down to every single endpoint of things like number of requests sent, errors, connections, and things like that. So now we'll walk you through a set of examples to actually show how you can use these APIs to actually understand things. So the very first example is mutual TLS and certificate rotation. So whenever you configure Kuma to use MTLS, what you'll end up doing is that. So you enable the backend that's called CA1, and then you define this backend. This backend has got a name CA1, as I just said, and we're using the built-in backend in that case. So the CA and its key will actually be stored in the data store of Kuma. It's good to get started, but we have other ones that might be more secure and more correct. For example, with Mesh, you can store all this in Vault. And then you specify a certificate rotation policy. In that case, we say 1 day. So every day, every certificate will only be valid for 24 hours. So whenever a sidecar connects to a control plane, the control plane will issue a certificate for the sidecar and send all the data down. It doesn't need to, like the control plane doesn't need to save anything about this certificate, because the certificate is only valid for the lifetime of the sidecar. If the sidecar restarts, it just gets a new certificate. Also, when it gets close to expiration time, the control plane will proactively renew the certificate. So that means certificate rotation is not something that your operators need to deal with anymore. This is all dealt by the service mesh. This certificate will contain in the SAN some information to identify precisely the sidecar. This takes form of SPIFE IDs. SPIFE is a protocol. It's a CNCF project with a spec that is very well defined. It's actually used by all service meshes. And a SPIFE ID in our case looks something like that. SPIFE default is the name of the mesh. We're just going to use the default mesh for all our examples. And then we have the name of the service here, which is called demo app Kuma demo service 5000. Whenever we're going to connect client to a server, each side will be able to verify that the other side actually has a SPIFE ID that they want. So that way you can easily say, I only want service X to be able to talk to me, or I don't want service Y to talk to me, and things like that. This is very easy, and it's all relying on these SPIFE IDs. So if we look at the configuration here, we can see that we use this certificate, and we're going to check that people that connect to us are in the same mesh. So they have a SAM that starts with preferred default. And then we're going to check that they're rooted on the CA of our default mesh. And then if we look at a certificate more precisely, we can see here that it's got a one-day validity. So now we went through mutual TLS, we can go one step up and rotating CA. Rotating CA is almost as easy. So what we do in our case is you had another CA backend, and then we're going to change the enable backend from CA1 to CA2. What will happen is new certificates will be issued on this new CA, but the old CA will still be sent to all sidecars. So sidecars will be able to accept connections from clients that have certificates issued on either CA1 or CA2. After our full rotation period, or even quicker if we want to, all the CA stands for certificate authority. So after the expiration period, so 1 day in our case, all our certificates will be reissued. So they will all be on CA2. When this has been done, we can just remove CA1, and that's it. We've rotated CA. So how about metrics? That's the second most common use case for service mesh, is being able to have a unified view of every service in your cluster. So every applications will have a set of standard metrics coming from your sidecars. So this is purely network metrics. So they're going to be HTTP response code and things like that, for example. So Envoy will expose the stats by default on 5670. We have a Prometheus scraper that will enable you to automatically discover and get these metrics everywhere. But your sidecar, you can also set it up so that it actually scrapes metric from your application as well. The advantage of that is that both your sidecar metrics and your application metrics are going to be exposed with the same labels. So it's very easy to build a common set of dashboards and things like that that will combine sidecar metrics with your application metrics. Also, these metrics will be identified with a common set of label, regardless of where they're run, whether it's Kubernetes, whether it's universal on VM, whether you're migrating from one to the other. It's a great way to actually provide abstractions in the process of migrating to Kubernetes, for example. You first get on a service mesh, you have a common set of view, you have a view of your network. And now when you're migrating, you can finally understand what happens. So application metrics is, whatever your application is gonna expose on metrics. So I don't know, like if you instrument your application with like a different set of KPIs, right, and you expose them on a port, which is commonly the case when you're using Prometheus and stuff like that. These are the kind of metrics we're going to be able to extract. Does that answer the question? Okay. One of the great advantages of that is you don't need to expose a port from your application outside of the pod. So everything is contained behind the sidecar and protected by the sidecar in some ways. So our next example is around endpoint discovery and load balancing. So whenever a pod is added or removed, or even goes unhealthy, the CP is going to recompute the configuration of all the clients of this service. Okay, so that means whenever we had an instance, all the clients that connect to the services in front of this instance will get this new instance. So it will suddenly start sending requests to it. Happens very quickly. It's usually under a second, and you can configure the load balancing algorithm that is used. If you're only using row Kubernetes, the only thing you can do is do round robin. Also, Kubernetes will abstract away the instances behind. So you won't be able to do very specific things that we'll show in following examples. So here, if we look at our inspect API here, and we look at our clusters, we can see there's 3 different instances, 22, 23, and 24. And in our case, they all received 23 requests. So what this enables us is to do things like outlier detection. So outlier detection is a policy that enables you to set up a threshold above which, a threshold of failure above which you will stop sending requests to the instance that breaks this threshold. So in our case, we're going to set a threshold of 15%. So any instance that has more than 15% of errors will stop receiving traffic. So if we take our example again with our 3 different instances, we get our first instance has a 100% success rate. So we can see it's healthy. It's going to keep receiving requests. The second one has an 81% success rate. So its failure rate is 91%. 81, sorry. Its failure rate is 19%, sorry. And so it has failed outlier check. So we will stop sending requests to it. And our third instance has a 90% success rate, and it's still healthy. So how about we take it down one level down? We put this threshold to 5% now. And so we can see that 2 instances are actually kicked out. This is great, and it can increase your SLO significantly. For example, if you have sometimes like Java processes that end up on slow GCs and posing and stop the world and stuff like that, you will be able to stop sending requests to these instances while it recovers, and then it will be coming back and will be able to get back to a good state. So the one problem with these kind of things is usually you implement them yourself, and the edge cases are tricky. And so what happens is you implement it, it works well, and then suddenly an upstream dependency actually starts failing, and you have a 40% rate, a 40% failure rate on every single instances. And so your outlier check actually kicks out all your instances, and you'll end up with a 0% success rate instead of a 60% success rate. So what is great is because we're leveraging Envoy, it already comes in with a bunch of different ways to avoid shooting yourself in the foot. In this specific case, you can set a max ejection %, where if more than 50% of the instances are considered as outliers, it will actually stop obeying to the outlier detector. So that means that in our previous example, where we have 2 instances out of 3 that is out, our outlier check will be completely ignored in that case. This can save you from a small outage getting even worse because of the bad outlier check. This is one of the great benefits of building on top of Envoy, as in Envoy is a pretty major software with a lot of different configurations. And so this is something, it comes in with a bunch of configurations that will enable you to specify very specific configurations to achieve the best availability and the highest reliability. So in conclusion, sidecars implement very complex algorithms as I've said, Envoy was built by Lyft and has contributions from a lot of places. I think every single public cloud has at least some components that are built on top of Envoy. And these algorithms are very solid. The configuration and the defaults are pretty good. And you can feel safe that this is going to be a lot better than whatever your application team will develop. Moreover, your application team can focus on providing value to your business rather than working on reliability algorithm that is neither their specialty, neither what will bring profit to your company. And then another point is, whenever you're evaluating the overhead of a service mesh, do remember to compare apples to apples. We sometimes have comparisons where people run their workload without the mesh, then they enable the mesh, they put the observability on, they put the MTLS on, and then they say, well, my latency and my CPU usage is higher. And it's like, yes, of course, you've got encryption and observability on top of that. So of course, there's going to be a cost to it. So do be careful when you're evaluating things to consider that. You should also consider the time that is saved on your engineers to not have to think about these kind of things. Also, in the event of outages, how your time to recovery is going to be improved thanks to the usage of a service mesh. The sort of example where I was saying, you have a problem with a timeout or an overload and stuff like that, and you can quickly jump and create a policy, push this policy, and get back to a better state until your application teams work on actually solving the bug that will then be pushed in production, and in which case you'll be able to remove this configuration. And then finally, if you're using Kuma, do use Kuma Coroll Inspect and the GUI that comes with it to figure out how things work. Internally, that's what the dev team uses a lot. That's sometimes what we ask in issues to actually figure out what's actually happening. So do get used to it because it has a lot of value. So that's about it. Thank you very much. And yeah, let's jump into Q&A.
Awesome, thanks, Charlie. So just a reminder, we have the Q&A tab at the bottom of the screen, so feel free to drop any questions that you have in there, and we have the remainder of the time for questions. One of the things I was hoping you could talk a little bit about, Charlie, that you kind of covered throughout, but just to kind of lay it out all together, what is the difference between Envoy, Kuma, and then Kong Mesh?
Right. So Envoy, let me get back to my very first slides. So Envoy is purely just the sidecar. So Envoy is a proxy that is used by Kuma and Kong Mesh, but also other service meshes to actually provide the sidecar functionality. Envoy has, like, the one great feature of Envoy in some ways is the XDS protocol that enables the proxy to be remotely configured by a server on the other side. So Envoy will be able to connect to the control plane in our case and get its configuration out. Then Kuma is a CNCF service mesh that will enable that, like, actually is a service mesh. Like, so it will enable you to run sidecars next to your instances, run a control plane that will enable you to create policies and apply these policies to a sidecar. And Kong Mesh is the enterprise offering built on top of Kuma, built by Kong, that will provide, like, more features and easier operational ability compared to Kuma. Cool. So there's I think, yeah, how much percent of CPU by Envoy versus pod? 5%, 10%, 20%. It does depend. It depends on what your pod does. So if your pod is actually just, just echo doing ping pong, it's quite likely that the vast majority of the thing will be Envoy, because Envoy will be doing all the heavy lifting. If your pod on the other side is actually doing complicated computation, the pod CPU will be higher. What we typically see in use cases is like it's pretty low to negligible. Does that answer, Musa, or do you have further questions? So Stephen is asking, Kuma being a data plane, does it route through Envoy for its configuration? Are Envoy and Kuma configurations separate entities from the control plane? So Kuma is like the whole service mesh, right? So it's both the control plane and the data plane, right? The data plane being like a very small body process and then Envoy. Okay. So, and then Kuma has configuration, right? And this configuration gets translated into Envoy configuration. Does that make sense? And yes, Musa, it's typically under 5%. No, so the CP runs like as a set of instances somewhere, right? Like it's a Kubernetes deployment, and that's the CP. And then your DPs are like your data plane proxies are going to start next to your app inside the same pod, right? So what we typically what we do in the case of Kubernetes is we have a webhook that will intercept the pod configuration and inject the sidecar container onto your pod configuration before it gets before it gets to Kubernetes. Does that? Okay, cool. Are there such situations in pod lifecycle where we would need to have in mind how Sidecar is behaving and tailor configuration to it? Yeah, so well, there's 3 questions here, so let's take them in order. So are there situations in pod lifecycle where we need to have in mind how Sidecar is behaving and tailor configuration to it? Yeah, so it's almost transparently, but not fully. Like, so because the sidecar redirects all the traffic, they like in some default cases, you don't have network like straight away when your app starts. So sometimes it requires the app to actually retry connections. Like, for example, if it connects to a database, it might like fail the first connection to the database, but then like the second one will succeed. So this is one thing that can happen. These kind of things, they're pretty minor, but there are edge cases where sometimes you do need to understand a little bit more like how things actually work inside. So Alan, if you have a follow-up to that, or if I haven't answered completely, just tell me again. And then can Kuma coexist with other ingress controllers and do rolling release service by service? Yeah, so Kuma really deals with the traffic inside of your cluster, right? So you can still have like an ingress controller. We, for example, support like Kubernetes, Kong ingress controller, and others, but like I'll talk about Kong ingress controller. But you can still use it. It still works the same way, really. So whatever you were doing before, you can still do. On top of that, you can also control inside your cluster and through route to actually selectively pick subset of instances that you might want to send traffic to on an east-west point of view, so even within your cluster. And then is multi-cluster mesh communication between multiple zones possible over private network? Yeah, so what happens is we have these little things called zone egress and zone ingress, zone egress being optional. And what will happen is when you go cross zones, you will actually go through this zone egress and contact this zone ingress. And this zone ingress is typically behind a load balancer. And so that's how it's reached. And then we'll reroute the traffic out to be able to reach a service. So that's how like multi-zone communication will work. So in that case, you have like 2 private networks and just a tiny bit that like actually needs to have a public IP. Well, public IP, like IP visible, like reachable from both. Okay, any more questions?
We'll still hang out for a bit if anyone has more questions, but I do have a quick poll would love to hear how you all liked today's presentation, just to help us with some of the content going forward. So I'm going to launch that really quickly here, if you all don't mind participating. I'm also going to drop a couple links in the chat down here so that if you have more questions after the fact or want to get more information, you will have those handy. So the first is our Slack channel. So if you have questions, please feel free to reach out to us on there. And then I will also drop the link to our community page. So this is where we have really all of our community channels for you to take advantage of, but also this is where the list of our upcoming tech talks are. So we would love to see you all at a future one of these as well. We talk about service mesh, we talk about gateways, ingress, all of that. So lots of great content on there coming up as well. All right. Let me just see. Yes, and then the recording of this session will be sent out via email. I tried to do same day, but within 24 hours at the latest, you'll get that along with a copy of the slides. All right, with that, I think we can wrap up. But Charlie, anything else before I wrap us up? Anything else you wanted to add?
No, thanks a lot. And yeah, don't hesitate to come on Slack. We'll like happily have a chat and help you out through your service mesh journey.
Yep, definitely. And once again, thank you all for taking the time to join us today. Thank you, Charlie, for the fantastic presentation. And we hope to see you all again at another one of these. So have a great day, everyone.
Thanks, everyone.